Welcome to the Resource Allocation Decision Tool, Help Video 2.3. My name is Terry Haines. This video focuses on the third key to success in using research evidence to inform resource allocation decision making, that being to focus on confidence intervals. In our previous video, we considered the experiment where we randomly allocated people to drink water or to drink coffee before then running 100 meters. We have hypothetically conducted this experiment now and have presented the results from all of our participants in the histograms below. Here the water drinking group has a number of people who have taken more than 14 seconds to run the 100 meters, whereas the coffee drinking group appears to be a little bit faster, with several people being able to complete the 100 meters in 12 seconds or under. So, who ran faster? Well, our coffee drinking group had an average speed of time of 12.3 seconds, whereas our water drinking or no coffee group had an average time of 13.7 seconds, creating a mean difference between groups of 1.4 seconds. So does this answer my question? No. All I know at the moment is that within my sample of 20 adults, those allocated to drink coffee ran faster than those allocated to drink water. What I'm actually interested in is what would happen more broadly than just my sample. Confidence intervals can be used to help extrapolate the results from our sample more broadly. Confidence intervals are a range of values so defined that there is a specified probability that the true value, when applied more broadly, will lie within it. 95% confidence intervals are conventionally used. Here I have added on red bars to our data to demonstrate the 95% confidence interval for the mean of each group. And as we can see from this graph, there appears to be some overlap in the range of the confidence intervals between these groups. So, does this answer my question? Well, no. All I know at the moment is that there appears to be some overlap in the confidence intervals in the mean time taken to run 100 meters between those allocated to drink coffee and those allocated to drink water. So what am I really interested in? I'm interested in the 95% confidence intervals of the difference between the means of running times for each group. Let's use a linear regression analysis to find this answer. Here we've got an output from a conventional statistical analysis software program and some of the data that you might see in a table in a research paper. Here the coefficient represents the difference between the means in time taken to run the 100 meters. As we mentioned before, this was 1.4 seconds. We can also see here the 95% confidence interval going from -3 seconds to positive 0.26 seconds. If we were to display this result graphically using a forest plot, we would see now we've got a horizontal line indicating the difference between the means and the 95% confidence interval of that difference being represented by a horizontal line. The mean difference, again, is 1.4 seconds in favour of the coffee drinking group, with a 95% confidence interval going from -3 seconds to positive 0.26 seconds. The null value in an analysis like this is 0 seconds and is represented by the thick black line. If the 95% confidence interval crosses this line, then we will not have a statistically significant finding. For there to be a significant result, the 95% confidence intervals must be completely to the left or to the right of that null value line. So, does this answer my question? Well, sort of. All I know at the moment is that there is no significant difference between the effect of drinking coffee and water on time to run 100 meters. Although there was a difference of 1.4 seconds between the means in my sample, I am not 95% confident that the true difference is actually in favour of coffee if I were to extrapolate this more broadly. Therefore, I'd be recommending that more research would be required. So, the keys to success here are that confidence intervals tell you where the true effect of an intervention might be when extrapolated beyond your sample. Having more patients in the study will likely make the confidence intervals narrower, creating greater certainty in where the true treatment effect might be when applied more broadly. Also, don't get carried away with trends in smaller studies with small sample sizes. If we're not at least 95% confident that the treatment has had an effect more broadly, then it's safe to assume that there is no effect until more research is conducted.